Hello, my name is Frank Silvera, and today I'll be discussing the results of Lab 7 Declocked Flip-Flop and Delatched. Um, so in this lab, we were tasked with constructing a D-type flip-flop and in one part, and a D latch in another part, and just verifying their functionality. Um, this is the D-type flip-flop we were tasked with creating, and here are my predicted values. So when the D input is 0, while there is a clock pulse, uh, uh, the output should also be 0, and the inverse output should also be 1. Uh, and of course, these are represented by D, Q, and Q hat respectively. Uh, and whenever the D input is 1, the Q output would also be 1, and the inverse output will be 0. And this is shown in my own circuit. As we can see, when the D output was set to 1, the Q output was also set to 1, so the LED, at least in multisim, would turn on. And this is just me taking a picture of the actual computer screen at the time, but here's a more better view. Again, when the input D was held high, the LED would come on, and when the input is held low or is low at 0, the regular Q output would be 0, but the inverse Q output uh, or would be high, therefore the LED would turn on. And next, we were tasked with the part 2. We were tasked with building a D latch, and as you could see, there were technically three states that it could be in. The first state, or I'll actually skip the first state and come back to it. The second and third states were basically the same as a D flip flop, a clock D flip flop, where while the except that an EN input was used rather than a clocked input. So when EN is held high and the D input is 0, of course Q will also be 0, and inverse Q output will be 1. And when EN is held high and the D input is 1, the Q input will also be 1, and the inverse Q output will be 0. However, when En is 0, the input of D actually doesn't matter. It will just hold whatever the Q output for that D input was previously, uh, and also the inverse Q output. It will just hold those two outputs, and they will be the same for whatever state D was previously in. And um, also, this is shown in my this is me taking a picture of the D latch on my computer. And as you can see, uh, when um, when D is set to 0, Q is also 0, and then inverse Q is 1, which means this LED light comes on. And when 1 is set to, or D is set to 1, Q is also 1, this LED comes on, and inverse Q is 0, so this LED light does not come on. And when EN is set to 0, it will hold whatever the previous D input was, and the previous D input, as you can see, was 0. And so the Q light still stays off, and the inverse Q light is on still. And when the EN is again set to 0, but the previous D input was 1, the Q light will stay on, and the inverse Q light will stay off. As you could see, this D latch kind of looks different than what they tasked us to make. That was because we could not find a D latch that had both the set and the reset inputs, so we just used a regular D latch, but it still resulted in the same truth table. Um, And so in the D-type flip-flop, why did we connect a 0 to set and the reset pins? Um, the reason why this occurs is because you kind of want to put the set and reset at an initialized position. So where like we start from 0 basically, and any sort of previous inputs don't matter, and this kind of like resets it and initializes it. And the lab did perform as expected. And what I learned was that a D latch uses a manually altering input in the form en, uh, while a DFF a clock DFF flip flop automatically switches from 0 to 1 with the clocked input. Um, and I also learned that a D latch has a no change condition where the previous input or the previous output will be stored whenever en is 0, while there is no store condition for a clocked D flip flop.